If I was your boyfriend, I'd never let you go. I could take you places you ain't never been before. Baby, take a chance so you'll never ever know. I got money in my hands that I really like to blow. Swipe, swipe, swipe on you. Chilling by the fire while we eating fondue. I don't know about me, but I know about you. So say hello to falsetto in 3, 2, swipe.
RAM, which is known as Random Access Memory, is commonly termed as memory where programs, application software, and data are stored. It also uses RAM to hold temporary instructions which are needed to compute tasks. This will enable the computer's CPU to access instructions and data stored in memory very quickly. The size of the RAM, which is measured by kilobytes, is an important indicator of the capacity of the computer. High-level software programs normally require a minimum of 64 megabytes of RAM. Computers also use RAM for video memory. The greater the RAM of the CPU, the better the quality of the video produced. In practical terms, having the programs loaded into memory means you can get work done more quickly and less time spent waiting for the computer to perform tasks. The process begins when you enter a command from your keyboard. The CPU interrupts the commands and instructs the hard drive to load the command or programs into memory. Once the data is loaded into memory, the CPU is enabled to access it much more quickly.
Now we will begin with the microprocessor, which is this object located right here. In this cubicle, it functions as the central processing unit, which is also known as CPU, of a computer that provides computational control and is also used in many advanced electronic systems such as computer printers, automobiles, and jet airliners. A microprocessor is also known as a type of ultra-large scale of the integrated circuit. Integrated circuits, or can be called as microchips, are complex electronic circuits consisting of extremely tiny components formed on a single thin flat piece of material known as a semiconductor. Modern microprocessors incorporate transistors, which act as electronic amplifiers, oscillators, or most commonly switches, in addition to other components such as resistors, diodes, capacitors, and wires. And they are all packed into an area about the size of a postage stamp. A microprocessor consists of several different sections. The first section is the logic unit, ALU, performs calculations on numbers and makes logical decisions. The registers are special memory locations for storing temporary information such as scratch or pad dust. The control unit, chippers, program buses carry digital information throughout the chips and computer, and local memory supports on chip computation. More complex microprocessors often contain other sections, such as sections of specialized memory called cache memory, to speed up the access to external data storage devices. Modern microprocessors cooperate with bus widths of 64 bits, the binary digits or units of informations represented as 1s and 0s, meaning that 64 bits of data can be transferred at the same time. A crystal oscillator in the computer provides a clock signal to coordinate all activities of the microprocessor. The clock speed of the most advanced microprocessors allows millions of computer instructions to be executed every second.
A hard disk drive is a device consists of one or more rigid rapidly rotating disks coated with magnetic material and with magnetic heads arranged to write data to the surface and read it from them. Among all of the functions that a hard disk drive does, the most important one is obviously acting as a storage for a CPU. They are designed to store large amount of digital information. This is accomplished by writing the binary data to a series of rotating magnetic platers. When the platers containing data are spun, the magnetic profile is read and the data can be detected and reconstructed by the computer. Hard drives are attached to the computer's motherboard, which governs the writing and reading of information. Another point is that a computer's hard drive also contains its operating system. In cases where multiple hard drives are accessed by the same computer, or when a single hard drive is partitioned into multiple sectors, the portion that contains the operating system is known as the startup disk. This is the hard drive that the computer will access when it is turned on, booting the operating system, and eventually displaying the user's familiar desktop interface. A CD-ROM, which is known as a compact disc read-only memory, is a pre-pressed compact disc that contains data accessible to but not writable by a computer for data storage and music playback. CD-ROMs are popularly used to distribute computer software, including video games and multimedia applications. Some of the CDs hold both computer data and audio with the capability of being played on a CD player, while data such as software or digital video is only usable on a computer, which are called enhanced CDs. CD-ROM drives can open documents on data CDs, such as music files, pictures, Word documents, and other files. However, CD-ROM drives cannot write information to a CD because they are read-only drives. CDs can be created in two forms, which is an audio CD and a data CD. Data CDs can be opened only by computers and other CD players, whereas audio CDs can be played by any CD players, such as in most newer car stereos or a portable CD player.
This tiny little black icon is a jumper. When a jumper is placed over two or more jumper pins, an electrical connection is made between them, and the equipment is thus instructed to activate certain settings accordingly. For example, with older PC systems, CPU speed and voltage settings were often made by setting jumpers. Informally, technicians often call setting jumpers strapping. To adjust the SCSI ID jumpers on a hard drive, for example, is to strap it up. In order to set a jumper on, the user has to place a jumper over the desired pins. To turn it off, it can simply be removed from the circuit without having to use any kind of tool. Jumper blocks and jumpers are also often used on motherboards to clear the CMOS information. Resetting the BIOS configuration settings, this allows the computer to boot if a recent BIOS setting made it unable to boot or if the CMOS boot password was forgotten. This small square thing with a white sticker on it is the BIOS. The full name of BIOS is Basic Input-Output System, also known as the System BIOS or ROM BIOS. The BIOS software is built into the PC and is the first code run by a PC when powered on boot firmware. When the PC starts up, the first job for the BIOS is the power on self-test, which initializes and identifies system devices such as the CPU, RAM, video display card, and keyboard and mouse. The BIOS then locates bootloader software held on a peripheral device such as a hard disk or a CD or DVD and loads and executes that software, giving it control of the PC. This process is known as booting or booting up, which is short for bootstrapping. BIOS software is stored on a non-volatile ROM chip on the motherboard. It is specifically designed to work with each particular model of computer, interfacing with various devices that make up the complementary chipset of the system. In modern computer systems, the BIOS chip's contents can be rewritten without removing it from the motherboard, allowing BIOS software to be upgraded in place. These 5 long and wide components here are the conventional PCI. The first one is the PCI X1, second is PCI X2, and PCI 3, PCI 4, PCI 5 for the third, fourth, and fifth one respectively. Conventional PCI, which is Peripheral Component Interconnect, is a computer bus for attaching hardware devices in a computer. The PCI bus supports the functions found on a processor bus, but in a standardized format that is independent of any particular processor. Devices connected to the bus appear to the processor to be connected directly to the processor bus and are assigned addresses in the processor's address space. The permitting bandwidth is either 32 or 64-bit. Attached devices can take either the form of an integrated circuit fitted onto the motherboard itself, called a planar device in the PCI specification, or an expansion card that fits into a slot. This round guy here is the CMOS battery. The CMOS battery supplies power to the system board to keep the time and the BIOS settings. If you pull the battery and then let the board discharge, up to an hour depending on the board, the date will default to the earliest time in the BIOS version. The BIOS will lose its custom settings and any BIOS password will be deleted.
As the backbone of a computer, the motherboard connects all system components and allows them to interact. The motherboard also determines the major characteristic of a system and affects your choice of CPU, memory, and expansion capabilities. If you ever open your computer like the one right here, as you can see, the bigger piece of silicon is the motherboard. Attached to the motherboard you will find the CPU, the memory RAM expansion slots, and PCI slots. It also includes controllers for devices such as the hard drive, the DVD drive, and of course keyboard and mouse. So basically the motherboard is what makes everything in your computer work together. So in short, we can say that the heart and soul of the PC data processing is CPU. But the processor is not alone in the world, it communicates with the rest of the motherboard. So before we analyze the circuit, we look at how the component in the computer connects to each other. So let's talk about how loads of data is being transferred in the motherboard in the first place. The first thing we consider right now is about buses. The bus in computing terms simply means passage of data transfer. Data packets may be 8, 16 or even up to 64 or more bits at a time are constantly being moved back and forth between the CPU and all the other components such as RAM, hard disk, and etc. It is these buses which connects all the components to each other. The buses are the data channels which connects the PC components together. Some are designed for small transfer, while others are for larger one. There's not only just one bus on the motherboard, there are several, but they are all interconnected so the data can run from one to another and hence reach the furthest corner of the motherboard. We can say that a bus system is subdivided into several branches. Some of the PC components work with enormous amount of data, while the others manage with much less. For example, the keyboard may only send a few bytes per second, whereas the working storage, which is the RAM, can send and receive several gigabytes per second. So you can attach the RAM and the keyboard to the same bus. The two buses with different capacity, or in other terms bandwidths, can be connected if we place a controller between them. Such a controller is often called a bridge. The entire bus system starts close to the CPU, where the traffic is greatest. From here, the buses work outwards towards the other components. Closest to the CPU, we find the working storage, which is the RAM. RAM is the component which has the very greatest data traffic and is therefore connected directly to the CPU by a particularly powerful bus. It is called the front side bus, or in older system, the system bus. The buses connecting the motherboard to the PC peripherals devices are called in or out buses. They are all managed by the controllers. These are small circuits which has been designed to look after a particular job, like moving data to and from EID devices, such as this hard disk over here. So actually a number of controllers are needed on the motherboard, as there are many different types of hardware devices which all need to be able to communicate with each other. Most of these controller functions are grouped together into a couple of larger chips, which together comprise the chipset. The most widespread chipset architecture consists of two chips, usually called the North and South bridges. This division applies to the most popular chipsets from VIA and Intel. The North bridge and the South bridge are connected by a powerful bus, which sometimes is called a link channel. The North bridge is a controller which controls the flow of data between the CPU and RAM and to the AGP port. As you can see here, the North bridge, which has a large heatsink attached to it. It gets hot because of the often very large amount of data traffic which passes through it. All around the north bridge you can see the devices it connects. The south bridge here incorporates a number of different controller functions. It looks after the transfer of data to and from the hard disk and all the other in or out devices, and pass this data into the link channel which connects to the north bridge. You can see over here, you can clearly note that south bridge is physically located close to the PCI slots which are used for in or out devices.